You're welcome.
All right. The geometry part of trigonometry is just the study of triangle measurement, as in mostly right triangles. Okay? We're going to talk about trigonometric ratios. Okay? And that's stemming from our similar triangles, but, you know, we'll circle back around to why it's a ratio. And then here are the three most common trig ratios. Sine. Okay? And you've seen these abbreviation on your calculators. Okay? First of all, we don't say sin. That's something that Jesus decides. Okay? It's sine, even though it's abbreviated that. Okay? And then you've seen this, and that is pronounced cosine. And then, of course, it's tangent. Okay? Even when you see TAN, it's tangent in math. It's not an. Okay? So, those are the three. There's three more that we don't do in geometry that you'll do in pre-calc. Okay, it's going to get me like 10, page 10, slide 10 is like what we're really going to do with this. So kind of bear with me because it just takes a while to get to what are you going to do with this. Okay, so first of all, let's talk about the sine ratio. Okay, please notice it is a fraction. That's what makes it a ratio. Okay, the sine of A. And whenever you say the sine, this is our angle right here, okay? So you should never write a sine or cosine or a tangent without an angle measure or something representing the angle after it, because it just doesn't make sense. Okay, so if you take, and this is all color-coded, but if you take the measure of the leg opposite angle A, here's angle A. Which leg is opposite angle A? We talked about opposite a long time ago, okay? BC. That's in red, okay? And then, of course, the hypotenuse is AB or BA, okay? So if we have a sine A, we also have a sine B, all right? So sine B, let's see who can tell me what the sine B is. Here's B up here, okay? So we're going to do leg opposite angle B. What leg is opposite angle B, Sophia? AC, very good. And again, the hypotenuse is still AB or BA, doesn't matter. Okay? So let's say this is a 6, 8, 10 right triangle. Okay? The sine of B would be what? 8 over 10 or 4/5. Okay. Now, when we did the special triangles, we learned that every 30, 60, or 45 has a special relationship. Well, we know every triangle with the 6, 8, 10 has a special relationship, too. The sine is always going to be 4/5. All right, let's talk about cosines. The same idea, except for grabbing different letters, different sides. Cosine says the measure of the leg adjacent to A. If you look at, here's A. What's the leg adjacent to A? It looks like it's in purple, AC. Wait, don't we have two things adjacent to A? Well, how do we know the difference then? Jessica? Good girl. The other one's the hypotenuse, okay? And then there's the hypotenuse down here again. Yes?
So what would cosine C?
We don't have a cosine C. That's a good question. We don't talk about, these are acute angles in geometry. Okay, excellent question. We do have a cosine B. Okay, who can tell me what cosine B is going to equal? Charlie?
Would it be BC over BA?
BC over BA. BC would be the leg adjacent to B. That's definitely this leg right here. Good. And then BA is the hypotenuse. Very good. Okay? That's cosine. And then the last one is tangent. Okay? Tangent says we're going to take the tangent to A says we're going to take the leg opposite A over the leg adjacent to A. Okay? So again, here's A. What's opposite across from is BC, and adjacent is AC. All right? We have a tangent B. You can tell me what tangent B is. No. Carla.
CA over BC.
CA, that's opposite B, that would be CA, good. And what'd you say?
Over BC.
BC, which is adjacent to B, which is in red.
I think you have some colors.
I did.
Put on.
I didn't for this. I didn't do any color coding for this. This is color coded.
Yeah, but that, no, it's color coded. Right? Isn't it? Oh God, okay. Carry on, sorry.
I made plain mistakes, so it
Because I
would
was
be
looking-
beyond the,
I was thinking of B, and then I wasn't looking at the A.
all right, so how are we going to remember these ratios? What? Is that like Elaine? All right, we have something called SOHCAHTOA. Okay? Yeah, I did not make that up. It's been around since I was your age, so that's been a long time.
Look at this, Indian battle.
That's why we have an Indian person over there. All right, yes. Okay, so this is one time when spelling does count. Because if you spell it wrong, you won't get the acronym, you won't get the benefit from knowing the acronym. Okay, SOH. The S stands for sign. The O stands for the opposite side. And the H stands for the hypotenuse. Okay? SOHCAHTOA. Ask any upperclassman, they will know what SOHCAHTOA is. Okay? They'll say, hey, do you know what SOHCAHTOA is? And they'll say, yes, with the right triangle tree. Okay, what do you think the C stands for? Cosine. Cosine equals, A stands for adjacent. Oh, good. Adjacent side over the hypotenuse. All right, very good. I'm going to make these different colors here. So I'm going to do adjacent, cosine, and H. And let's color. Cosine, adjacent, hypotenuse. Okay?
Could be blue.
Oh, gosh.
Jessica.
Sorry.
Noah.
You're right, you're right. Okay. So TOA, what do you think that stands for? Tangent is opposite over adjacent. All right. Yes, and that's assumed we have legs here. Opposite leg, adjacent. All right, so I need to use purple now, right? O-A-T-O-A. Okay, so you gotta know it, you gotta know how to spell it. Tangent, opposite over adjacent. Now, if you want to look real closely, remember here's the tangent, here's the leg opposite, here's the leg adjacent. Cosine, here's the leg adjacent over hypotenuse, C-A-H. And sine, here's the opposite over hypotenuse, S-O-H. Okay? All right, very good. Y'all caught on that quickly. Okay, now, again, this is, like, we don't usually do this, but it's just getting used to finding sine of R, then cosine of R, then tangent of R. And we have another acute angle. We're going to do it with S as well. Okay? Remember, it's just a ratio. If we have a whatever 3, 4, 5 triangle, okay, even every sine of the 3, 4, 5 triangle of the R is going to be the same. Okay, so who can give me the sign of R in terms of, I guess let's start with the letter signs first. Go ahead, Catherine. ST over SR, she says. Remember, sine is supposed to be opposite over hypotenuse. Let's write that. So, So, all right, opposite R. Here's opposite R. That looks good. And hypotenuse, I'm just going to label that hypotenuse right now so you don't forget that. Okay, so that looks good, which would really be what? 4/5. Okay, and as a decimal, that is what? 0.8. Good job. Okay, so that one's done. All right, let's do cosine of R. I'll erase this. Cosine of R in terms of sine. Scarlett.
Would it be RT over SR?
RT over SR, Carmen says. Cosine is supposed to be A over H. So R hypotenuse or adjacent would be TR, yep. And there's that hypotenuse again. So what are we talking about in terms of numbers? 3/5, which is also 1/6. Okay? All right, tangent of R. Who's got my tangent of R here? Rachel.
It would be the opposite, which is SR over the adjacent, which TR.
Okay, these are both legs. Opposite R.
Oh wait, never mind. Never mind.
So what's my opposite, Rachel?
The opposite would be ST.
ST.
Sorry, I was thinking.
That's okay. And adjacent?
The adjacent would be RT.
Okay. Or what? 4/3? Okay. And the decimal for that is a repeating decimal. Okay? All right. Do the sign of essence. And you can cut right to the numbers if you'd like. And then we'll kind of. So, what do we have here? Sign of S equals, let's see, 3/5? Okay. Because remember, we're talking about S, we have a relative different opposite, right? The hypotenuse is the same, but the opposite. What about cosine of S? Okay. Adjacent over hypotenuse and tangent. All right. So your, what we got? 0.6, 0.8, and 0.7. Nice. Anybody have any issues with that? Very good. All right. Okay. So let's get our calculators out. And I don't know. I know Jessica shares her calculator. Does anybody else share a calculator? With yourself. Good. Then yourself should not be changing. I want you to look at this mode button right there. Okay? And I need you to, if you've never messed with this, it's probably not on the right mode. Okay? This mode button right here. See, this says degrees. We are in geometry, we mess with degrees. So when you press the mode button, what is highlighted down here on the fourth line? Is it radian or is it degrees?
Degrees.
Okay, then you're good. You don't have to do anything else. Okay, if you're at radian, like mine is, I need to go over here to degree with the right button and press enter. Now I'm good. Because when I scroll up and down, degree is now highlighted. So Jessica, you need to make sure that Jen doesn't switch that up for you because all your inches will be wrong. It's a different measurement. It's like inches and feet. It's totally different. So just be careful. Now you all, if you don't mess with it, it won't mess with. If you do any gaming, does anybody do any gaming on their calculator anymore? Okay. Do you? Really? Okay. If you do, I forgot, did I turn this back on?
How do you get out of this?
Okay. Anytime you want to get out of something, you just do second quit, and then you're back to the home screen. Second quit. Second quit. Okay.
I still hardly know how.
All right. So now here we go. These are, we're just going to use the calculator. There's no way you would know this unless there's a triangle sitting there. Okay. Cosine. COS. 39. Now the calculator knows, oh yeah, right, that's in degrees. Close your parentheses, it's just a good habit. Enter, and that is that number. Okay, now, you looked at the directions, it says nearest 10,000. How many places is that after decimal? Tens, hundreds, thousands, 10,000s, good. So 0.777, what's my last digit? 1, because 4 doesn't round up. Very good. Okay? Do the same with sine 67. Sine should be right next to cosine. 67 close parentheses.
Are any of these going to be pretty numbers?
No, not very many of them. Like 30 is, depending on if you take the tangent of it, cosine 45. Yes. Okay, so what's this one? 0.9205. Okay, and then last one, tangent of 30. Tangent of 30.
5774.
0.5774. Good job, Elena.
I'm just looking at it and I'm like,
Okay. Remember, you round, you can't just cut off. You got to look at the digit right after it's a 5 or above it rounds up, right? Okay, so that's how you use your calculator. The sine and the cosine and the tangent are in the order that we remember the SOHCAHTOA, so that'll help too. Okay.
in the degree thing, if I just break that out, you have to go left.
No, that won't affect anything else. The only thing it affects is trig. I actually did something in calculus today, and the answer was really funky, and I was like, oh, shoot, I'm in the wrong mode. So, okay, so this is really what we need to use trig for, what we're going to do on this page and the following page, okay? It is up there with the Pythagorean theorem as far as, remember, we had a right triangle, and we said, okay, if we have two sides, we can get the third using the Pythagorean theorem, okay? The trig, we can have an angle and a side and get any of the other three sides, okay, and the other angles, okay? So, first of all, we're going to use trig, sine, tangent, or cosine, so this is how we have to figure out. We're going to use this angle. Yes, we know this angle, but we don't need to use it, right? We're going to use this one.
Do they have to be right triangles?
Yes, they have to be right triangles, yes. Okay, we don't care about this angle. We're going to use this one. So, if we are using this angle, then what is this side going to be? Opposite, adjacent, or hypotenuse to 43? Okay. Adjacent. So I'm going to put a little A there for adjacent. Okay. What is the X, which is the other one that we want to know about? What is it, Tara? Opposite or hypotenuse? Opposite. Okay. So that's what you do. You say, okay, I'm going to have to use the function that uses the O and the A. Which one would that be? Tangent. Very good. So I'm going to write tangents. And remember, we never write tangent without an angle beside it. So what's next? Oh my gosh. Sorry. Going discount. Are you okay? Yeah. Okay, what's the rest of it look like? Go ahead. Tangent of, what's the angle? 43 degrees equals x over 15. Okay? All right, now we're going to solve it for x. Okay, how do we solve for x?
Well, you have to find the period first.
No, we don't. We're going to do that later. How do we solve it for x? Like get x by itself. Well, technically, you're going to multiply each side by 15. Okay. All right, so x equals 15 times tangent 43. Now you put that in your calculator, just like that. Okay? Because if we put that in our calculator before that, then we get this big ugly number that we have to, what the heck? I'm not sure what is going on.
What should we round to?
All right. First, let's go to, let's just look at our number and we'll kind of make a decision. Just get used to closing that parentheses off. I know it doesn't matter at this point, but it will eventually. Okay, so 15 times tangent 43 is, let's go to nearest whole. So, x is nearest whole number. What is it? 14. Okay? Now, depending on this angle, 43 is pretty close to 45, isn't it? So these should be pretty close to the same, shouldn't they?
Yeah.
Okay, so that makes sense. Right? All right, let's do this one. Get this out here. Okay. Again, we have a 35M, which is just a meter, a unit. Okay, we have a 20-degree angle, and we have an X here. So we have to go through and we have to say, all right, we're going to use 20 because it would be silly not to. We could use 60, but why? Or no, 70, right? Okay. So what is 35 to this angle 20? Jessica? Adjacent, so I'm going to put a little A there. Okay, and X is, again, I've patented it, so it wasn't again, but it was used last time. All right, so what function, that doesn't look like an H, what function do I want to use? A and H, cosine, good job. So, who would finish that statement for me? Cosine, Ellie Madeline. 20.
Equals 35, no wait, yeah, 35 over X.
Very good, okay. X is at the bottom, we don't like X on the bottom, do we? So the first thing we should probably do is multiply by X. Okay, use your good algebra skills here. All right, now how do we get X by itself?
Divide both sides by cosine.
By what?
Cosine 20.
Good job. The cosine 20 is a number, but there's no point in messing with a number that's this long when we can mess with cosine 20. Okay? So now you're ready for the calculator.
I'm not gonna lie, I keep wanting to say cos.
I know. 35 cosine 20. Yes, I get really mad.
And what number again?
Let's go to tenths this time. So, nearest tenth.
This is fun. These press button buttons on the tab.
Yep. So what's that? 37.32.
32. Oh, 2.
2. All right.
37.
37.2. Okay.
I think they're like a nap time. We should start the Jonas Brothers YouTube channel.
Yeah, I agree. Okay.
That'll be your
37.2. All right. What about? You want to try this one by yourself? Are you ready? All right. Yes. Let me stop this. Try this. If we're going to use 25, this would be opposite, right? And this is hypotenuse, so we're going to use sine. Sine of 25 equals 3 over x. Multiply both sides by x. Use good algebra skills, then you won't make a mistake. Sine of 25, sine of 25. Plug in, and what do we get? To nearest 10. 7.1. Okay? All right, let's find y here, however you want, on that same triangle. And then we'll talk about what kind of things. Everybody is at 6.4. Okay. Many of you all did tangent equals this, right? Who did that? Raise your hand. Okay. Now, that was smart if you were going to use trig. I'm not saying that this wasn't as smart, but it isn't. Just saying. I bet you can tell me why. Let's see. Could you have done, we're looking for y, could you have done sine, no, cosine, yes, that's the one. Thanks. Cosine of 20 equals y over 6.1. Why is that not as probably good as the other one? 7.1, sorry, that's not right, but yeah. Why is this one not as good as this one would be better? Jessica, tell me why. Right. And this is rounded. Okay. So if you do that, you need to go back to that big long answer, not the rounded answer, because your answer is going to be off. But I can show you how to do that if you have to. Okay. What about Pythagorean theorem? Did anybody do that? I feel like you did. Wow. Okay. So what does that look like? Did you also get 6.4?
Yes.
Okay. So you did what?
9 plus x squared equals 50.41.
Okay.
That's what I have.
This,
40.
we need to use a longer answer, otherwise it might be not quite so accurate. Okay? All right. Did anybody use a 65-degree angle? This was 65. Okay, so let's say we want to use the 65-degree angle just to be different. Okay? Because what would be the best trig function to use? So we don't have to do any rounding, premature rounding, they call it. And we're looking for y. So what would be probably y and 3 that we'd use, right? Which function would that be, Emma? Tangent. So let's do it. Tangent of 65 equals y over 3. Look how nice that's going to be, because y is going to be 3 times tangent of 65. Okay? Tangent of 65, 3 tangents of 65, there's your 6.4 again. Okay? So you're going to have lots of options, ladies. You just have to make good decisions about. Okay, let's say, let me put this in. 3 over 525. Everybody look up here. Okay, that's 7.1 when we round it, right? Okay, if we were going to do some of your, right here. Okay, from this answer is stored as the real answer. Yes, it's rounded eventually, but inside there that you can't see, I'm going to square it. Okay, there I am. Now what could I do to solve this? That's 50.39, blah, blah, blah. Subtract 9. Okay. Subtract 9. And then square root. Now I don't want to type that whole thing back in. How do I get that 41 to pop up in there? Okay, I can do that. Okay. All right. Or here's what else I could do. Let's say I'm back here. This is my last answer. Okay, and now I want to take the square root of that. There's a blue ANS there. You see it on your calculator? Yeah. That means hit the blue button, hit that button, and it'll throw this answer in there without throwing it in there. You can only do it with the very last answer. Press enter, and there's your 6.4 again. Okay? Okay, I did the 7 point, whoops.
What would you break?
Nothing. Okay. The 7.1 squared, it didn't end up getting a different answer, but sometimes it does when you round too soon. Okay. Now, go ahead, find x, find y, whatever you like. Try to think of a different